Okay. Hi, my name is Liam. I'm a rising senior at Regis High School, and this is my last milestone video. So what I've been working on since completing the line following aspect of my project is some code which will allow me to get more control over the spider. And I started learning Python a few weeks ago, so I figured I might as well incorporate that into the program. So basically what I've been doing is I've been writing a few Python programs which would communicate with Arduino over the serial port wirelessly in order to control the Arduino and the spider in a couple of different ways. So this is what it's using right here to speak to the computer and the Python program wirelessly. It's called an XBee, and it sends serial data from here to the other one, which is right here on the computer. And I've got a couple of different programs. I've got the original line following mode, and I've also got mode where the user can essentially put in a speed where they want the spider to move in and the distance they want it to go. And I basically calculate the speed and the distance using a linear regression model that I created using a few data points, putting in different voltages. And then the last one is what I'm calling, I guess, total control mode, because I assign basically the ability to control the spider to the keyboard. So by pressing different keys, it'll walk, you can increase the speed, you can get it to turn. So that is it was created, and then also I created this HTML interface right here, which basically has links to all of them, all of the executable programs, so you can click on them. It's pretty terrible looking, but I'm not an amazing artist, but I know I was pretty happy with the way it turned out. So now I guess I'll go ahead and demo.
I'll put this in.
Okay, so now it's actually running, and you can actually kind of see the program right here in the command prompt, and it's telling the user a variety of things. You know, this is the user input mode. It's telling you, what you can do, how it works. And the first thing that comes up is, do you prefer miles per hour, meters per second? I'm going to say miles per hour. What speed do you want? Well, based on the limits, I'm going to say, okay, let's go for 0.178 miles per hour. Not the fast in the world, but still. Alright, so now it tells me what direction I want him to go. I'm just going to have him turn left. And how far? I don't want him running off the table, so like maybe 20 centimeters or so. And that sends it so he turns to the left, and there we go. Yeah, that's about 20 centimeters or so. So that's one mode. So now let's try out another mode. Let's say go to the one where I control him just using the keys. So make sure he's put down everything. So, alright. So now this is coming up and says, okay, let's move on. When you're ready to start, hit enter. So I hit enter. Now let's say I want him to turn. Hit that. Starts turning. And I want to say, okay, stop turn. Hit it again. Whoops. There we go. That's what happens. And then I say, okay, I want you to walk forward. So let's do that. I want you to slow down a bit though. No, slow down too much. Whoops. Static friction is a bit of a problem. And I can say stop again, and turn again, stop again, and then put up the speed and start walking again if static friction works. That's a problem. So the program itself works pretty well. One of the main issues that I have faced along the way has been my worst enemy, static friction. I've tried to combat in a number of ways. At first I can only give it the motor 5 volts direct, so what I did is I ended up hooking up the motor directly to the 9-volt battery and then putting transistors after the load so that I could control the voltage going to it, which has worked fairly well because it's given me more control of range. But again, as I add on more pieces like the XBee and indeed putting battery on top, static friction's definitely been a big issue that I've had to deal with, because again, in the end, it's a small sort of robot. The motor is the most powerful thing in the world. It's dealing with a lot of weight. But that being said, it still works pretty well, and pretty cool to work with. Alright, so thanks for watching.